We are going to go on a journey through trees, backgrounds, animations, and interactivity. We can go faster, and the wagon wheel effect is already taking place, or we could go slower and actually go in reverse speed to make sure that there is an extreme wagon wheel effect where the bicycle wheels appear to be still while the trees are still moving. Let's get into it. I briefly introduce you Turtle, what Turtle is, and our plan to draw out this animation. First, we are going to configure. This means we are going to import all the required modules, as this is also requires lots of mathematics and calculations. We are also going to need a bit efficiency when drawing this, which is why we have speed setters, where we use speed 0 and tracer 0. Speed 0 affecting turtle speed and tracer 0 affecting frame display. Next, we are going to have some parameters for our animations. First, we're going to have bike parameters, and we are also going to have background parameters. First, our bike parameters will surface is going to be minus 100. Excuse me. Excuse me. As our plan, we are going to draw our backgrounds first. We are going to use a special turtle for backgrounds drawing. First, we are going to define a robot turtle called Grass. Our plan here is basically to draw a huge green box with a top yellow border, and the top yellow border will represent the bicycle path, and the huge green block under the yellow border, under the yellow path, will represent the grass, and all the rest of the yellow border slash green box will be off the screen and will not be visible to the eye, which is one of many programming tricks that I use in this tutorial, or rather showcase. Grass.speed 0 for efficiency, which is going to, our width is going to be the width of the path, the bicycle track, lime, which is a color of grass. Lime is basically bright green. Yellow, grass dot up, because we don't want any trails just yet. Dot go to minus 2000 surface 10 grass dot. We have finished configuring, and now we are actually going to draw. Now let's go to wait for 4000 grass dot. This is how we are going to draw the huge box. It's going to go off screen. If we want to see all the results at the end, otherwise it's just going to be a flash, so we're going to have the command done. And this is a problem with using tracer 0. We have to use a special command called update, which refers to the screen, and the updates command changes the frame of the screen, and we have a problem. We just have a center turtle and a yellow border that has nothing beneath it. This is because I forgot grass.end fill. Here, here we have successfully achieved part of the background. The rest of the background is easily adjustable. We simply use the command background color blue, and okay, not this kind of blue, but sky blue. It just is exactly the background that we used to have for the in the introduction. Right now, we have finished the background. The last bit of the background that we're going to draw are the trees. The trees, the trees simply are going to be trees. We are going to define a class called trees. So this is called object-oriented programming. Sound stroke, height, stroke width, leaves size, X core, initial Y core. Don't know why I have so many parameters where they're always going to be fixed in mine drawings. But trunk. Every tree needs to have a trunk. So we are going to define a turtle. Self.trunk equals turtle. Shape equals square. And notes that I am using the turtle itself to denote a tree, to represent a tree, instead of getting the turtle to draw it out. Because if it's the turtle itself that is the tree, that is in the shape of a tree, it is able to move. Because drawings can't move, but turtle robots themselves can, which is the key for animations of objects. Trunks have the color of brown, not black, as default, not as default of turtle. Self.trunk dot shape size. It's not just a small 20 pixel size square, but rather how we define it to be. Stretch width equals trunk width. Stretch trunk. Now we have a trunk, but a tree trunk without leaves is what we have in winter. Right now, we are drawing what it looks like on a beautiful summer's day. So we're going to need some leaves. So the leaf. The leaves in the intro looks like a circle. Shape equals circle. Self dot green. This is how we're going to draw leaves. And there's going to be lots and lots of leaves, so they need a big shape size. We are also going to set the parameters at the beginning. To the right side. I'm just going to shift this up to the top so that our program looks neater. We need to have structure within program so that it looks neat, so that it is easy to edit. We're also going to have a new set of variables for background parameters. Our tree trunk width will be 2 times 10 pixels fat, because shape sizes for because when we use shape size for turtle shapes, is going to be every 1 unit is 10 pixels. Height will be 150 pixels tall, and it will occupy. And tree leaf size will occupy a circle with a radius of 200 pixels, which is which is which so that the tree looks normal, so that the tree has lots of leaves. Right, now we've done the trunk drawing, we just need the trunk positioning, because they might be in the wrong order, because we've defined a turtle to be bad. Leaves positioning, trunk self.trunk.up, self.trunk.color brown, self.trunk. What am I typing? Self.trunk.right 90, so that they face in the right direction, upright instead of horizontally. Otherwise, a tree would be dead. And the go-to command will make sure that the tree is in the right place, and also that it's in the. And we're also going to have a command in trees that enables a tree to move relative to the bike. The leaves will need to be the same. Self.leaves.r. So the leaves dot go to init x core, init y core. Well, actually, plus 200, because the leaves need to be on top of the trunk. This command actually is not necessary. We all make mistakes with humans. Animation of movement. Here, we are now going to create the. Okay, nah. We're not going to go into that just yet. We're not going to go into the fancy animations yet. We're just going to make sure that we could create trees successfully. Background display. Background draw. Just to make the code slightly neater, we're going to remove this background color drawing. I'm going to put it here. We need new code. we need neat code. Imagine if, as I've said, and we're going to use a list to define multiple trees because I can't just use a for I range 7 trees dot tree trunk height tree trunk width. Oh, there were basically parameters that I defined at the beginning of the code. So 2 pixels fat, 15 pixel to 20 pixels fat, 150 pixels tall, and with leaves occupying the radius of 200 pixels. Tree trunk height, tree trunk width, tree leaf size, and we're also going to use a calculation that's to do with the index to make sure that the trees are evenly spaced apart. Minus 50, 50, 100. Uh, uh, 500 minus 50, 100, surface level. It's basically how we adjust trees and surface level for the Y core. Let's see what we have right now. We have an error. Of course, we're going to have an error. Oh, of course, it's probably bad. Let's see what the. So the tree. Why is this called trees? Oh, we've got a set of trees, which means that we have officially completed drawing the background. Hooray! That's part 1 in our plan complete. So we're going to do a check mark. Oh, can't really do a check mark here, but but we've done it. This is as close as I could get. Oh, I know. This one. That's a check. Alright. We've done our background. Next thing we've got to do is to draw the bicycle. For the bicycle, we are going to have a sequence of commands for the main turtle to draw the bicycle, for the bike head and the frame, and also the pedals. Right. We are not going to draw the wheels yet. We're going to have a class do it instead, or rather the object. Wheels setup. Okay, not yet. Bike head drawing. Shape circle. For the purposes, we're just going to have shape of circle. We need a shape of a circle. Actually, it's not really relevant now, but it will be later. Go to wheel 1x. Have we defined that yet? No, we haven't. So we have to go back to variables and define what wheel size rate. So the x positions of wheels of the first wheel and the second wheel will be wheel 1x will be equal to minus 150. Wheel 2x will just be positive 50. Right. Now we're going to go to wheel 1x, making sure that the bike frame is fat enough, not too slim. So our fatness is going to be perfect with width 10. Then go to minus 90, 80. And already we have a problem. Oh, of course, because we need two parameters, not one. So that's wheel 1x, surface level. Oh, so we've done something here. It's just covered by the trees. In fact, I'm just going to comment out how to draw the trees. For now, the trees will come back. Right now, we've got a bicycle head fin, or the bar that connects the head to the front wheel. Go right. The next command is going to be go to minus 125. Oh God. Okay, it's not. Oh God, but we've got a head now. In fact, even though it's different from the original, I'm going to stamp because it looks nice. And then we're going to go take the pen off the page. Minus 150 down. Where we are at now? Oh, we're here. That's currently the turtle is represented by the circle. Now we've finished drawing the head, we're going to draw the frame. Just adjust the brightness because it's today's coincidentally a summer's day. Shape circle. We need speech marks here. Up, down. Oh my gosh. Whoops. Go to wheel 1x, surface level. Let's see what result it gets us to. Oh, it gets us back to the wheel frame. Oh, of course. I'm just copying off I've just written wrong code. Repeating myself. That's actually very bad. We're going to draw the frame. I've written specific coordinates, so I'm just going to. If you don't have time to catch up, I'll give you a bit of time now. Catch up as I go. Oh, what did that just do? It just went down there and went back up. 75, 25. Oh, we're going to draw a triangle. Go to 25 minus 100. Okay, not 25 minus 100. That's minus 75. But how did I manage that? Ooh. Now we're here. Right. Next, we're going to draw the pedals. And through testing, I have found out that the perfect shape size for pedal frames is 1.7, which equates to 17 pixels of radius size for the turtle. And when we stamp, it leaves behind a mark like that, which will represent the pedals, and which already looks nice. Next, we're going to draw saddle plus the rest of the frame. go to 75,25. I'm just providing turtle directions. Providing turtle directions. Like, ooh, okay. So we go back 74. Oh, am I even copying the correct things? Well, I've messed up here again. We're not meant to go back there. We're meant to go to the second wheel center. Wheel 2x surface level. And we're back at the center of the second wheel. 25 comma minus 100. Uh, oh, nice. This is why we have This is why we have IDs. It enables me to debug. It enables me to find out logic errors and also syntax errors. 85, 50. Shape. And kinds of. Oh, it's already a shape, so why am I doing that again? Moving that. Stretch length equals 3 stretch. So I'm turning the circle into an ellipse kind of thing. Well, it's different from an oval because oval is not an ellipse nor a circle, but something round. Stamp so that the saddle stays permanent there. Hide turtle up. Right, we can't see the turtle anymore, but its mark, its legacy is still there as a saddle, and it will stay there, and it's going to be a very nice view. It's going to go on a very lovely bike ride, hopefully, unless it has other jobs to do. Don't think it actually does have any more jobs to do. We've just completed a bicycle frame. Now, we've done the bicycle half of it, so we're going to do a half tick. All right. We're going to go back to object-oriented programming. I'm just going to add a list of equal size to make it clear that this is a... Okay, that's too many. Class wheel. Define initialize center X, center Y, size, spokes. XY refer to coordinates, width. I don't know why I have so many parameters. I never change them. Turtle configuration. For goodness sake. How many typos have I done today? Self.spokes cause for range. The spokes will need to rotate, and this will create a wagon wheel effect eventually. Once they each have to rotate 45 degrees in turn, and then becomes only after they finish 45-degree rotation, the frame will appear, and then only once they are finished, the frame appears, and then essentially after they do it, the first each spoke has occupied the position of the spoke adjacent to it, or rather the next spoke. Self.spokes turtle attend. Ha 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 ha. Imagine Imagine spokes attended a meeting called Turtle. It's actually called a pen. Spokes. Oh, spikes. Initialization. With throwaway variable equals 1. If the spoke is self.spokes. Yep, self.spokes. Any list is an iterable. Of course, spokes are not squares, but rather really long rectangles. We're just stretching out a square to be really long here. Oh, no. Equals psi. What's that? Equals size divided by 100. Through testing, I found out that this is the most optimal size configuration. Spoke.left. Oh, no. Oh, 180 divided by spokes times by underscore. This is a formula to calculate. This is a formula to calculate how much we need to rotate it by. This is basically the position that we need to occupy. So interval size, and then how many interval count. Spoke the up. Spoke the go to center X, center Y, so that their centers will all be at the center of the has a center of the coordinate at the center of the wheel, so that the animation looks real and nothing strange or odd. And the throwaway variable needs to go up by 1 so that the interval interval takes effect. Now we are going to code the wheel rim. Wheel rim drawing. Rim equals pen. Rim dot speed 0. Rim dot up. Rim dot down. But first we need to go to rim dot go to center X, center Y. Rim dot forward. Right, we've done here. Now, let's... Okay, we're not done yet, but we've just configured now the turtle is at the rim of the wheel. We're just going to turn left by 90. We're going to rim width. We've defined a parameter that does that for us. Rim dot circle size 10 times 10. Let's see what this can do for us. We're going to define and draw them out now. Wheel setup. We're going to do it here. Actually, we're going to do it after grass footpath. Grass plus wheel setup, wheel front, equals wheel first x coordinates, surface level, size 410. Oh wait, what's size again? Oh, size is. Oh, we haven't defined size yet. We will define size as 10 because through testing I found out that's optimal again. And speed is equals to 10. I'm really skeptical about this because I'm scared that this variable speed will change the speed function I've imported from Turtle. But but of course that never happens because speed is only ever used again as a method of another object which is not defined as just 10. Oh, we've got one wheel. Where's the other wheel? Oh, there it is. I haven't defined it yet. We're not going to call it wheel front. That's just a copy. We're going to call it wheel back, and we're going to have it shifted to wheel 2x, so the second x coordinate. This is what our final bicycle will look like, and that's our bicycle fully complete. So we could go back to our top checklist, and we could tick it. Next, oh, why did I put trees there? We're going to delete that because we've already done that. That was actually already part of the backgrounds. And now, interactivity. We actually have not done trees, but I can easily bring it back right. Okay. Okay, sorry, I'm gonna undo something. We've 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 almost done trees. We just go to uncomment that, and we've got trees back. The bicycle is now blocked by trees. We're almost done. Now we just need to. Now, if I press left, if I press right, the bicycle doesn't move. We need the bicycle to move. Hello, bicycle. Can you move? Okay, that's not going to do anything. We're going to write code in order to make bicycles cycle so that the turtle could go on a lovely bike ride on a lovely summer's day. Spokes animation. Define spin self.speed. Oh, of course, it's not self dot, it's self comma because that actually is ridiculous. For spoke is self dot spokes. Oh wow. Spoke dot lefts. Wake up! Can you hear me? Okay. What has this done me? Okay, it's done me nothing good. What I've just done is define a method. Alright, next step. Because if this wheel is spinning now, it's going to spin, move forward, and we also have to change. We also have to make the trees look like that it's moving forward. Animation of movement. Define move back self speed. Self control set x. Ooh, what should I set it out as? Self.trunk.x core plus speed leaves.setx self.trunk.leaves.x core plus speed. Other, we only need to change the set x. The y coordinate will stay the same for the rest of this animation. Unfortunately, this will mean that the trees will eventually move off screen. So we're going to have a reset command. When tree moves off screen, it goes back in front or back for negative speeds of the high of the bike. This is just another of my many animation tricks in the video. Define reset. Oh, rest in self. Positive, negative. Oh, what's position? So try the X core plus 3,500 times positive, negative. Self dot shrug dot self dot. I should set it to a throwaway variable. In fact, I'm not. X. Oh no! In fact, I should be setting it to direction. Plus 3,500 times positive, positive, negative. Right now, still nothing. We've only just defined methods now. We've now got to use the methods. Here, uh, here I'm just going to have a warning. I'm going to remove the command done. Here we're going to start an infinite loop. It's going to go on. It's going to go on for the rest of the program's existence, or for the program run's existence. Listen. Okay, not yet. Tree in trees. If tree dot move back speed. Oh, what does move back mean? I forgot again. Oh, it means move back here to adjust to speed. Oh yes, move back as in because if the bike moves forward, if the bike moves forward and the bike stays still, the trees have to move back to make to give the illusion the the give the illusion for the camera frame that is fixed onto the bike. Tree dot move back speed. Tree dot tree. Then if tree dot trunk dot x core greater than or and speed greater than 0, tree dot reset minus 1, or if tree dot trunk dot x core smaller than minus 2000 and speed, oh wow, smaller than 0, tree dot reset 1. Oh, whoops. Right now, we've done nothing because we haven't actually changed speed. Speed. Oh, okay, we're stuck in an infinite while loop. Right, that was a blunder. Programs take forever to close when they are stuck in while loops. So we go to do a command called update. And we've defined speed equals 10 already, so that's not a problem. Oh, yeah, isn't that slow? Well, at least the trees are moving, but I'm not going to need an update here anymore because I've already got an update in the loop. Even though it's poor and we're also going to do wheel back. Wheel front, of course. Uh, Back row. Uh, oh, it's spinning now. Yeah, but why is it so slow? Don't get why it's so slow. Maybe I forgot to set speed equals 0 somewhere. Just don't get how it's so slow. This is so. Set speed to 0 in here. Maybe I've set rib speed to 0. Well, spoke is already 0. Well, I'm going to try to see whether I could do something with the trunk. Self.trunk.speed 0. Self.leaves.speed 0. Oh, it does nothing to the speed. Let's see if that's still. Let's see if this is still. This is still spinning really nicely. But this. Oh, okay, but rather this. Oh, yeah, I've shut it down, sorry. But this is spinning nicely. Whereas here, it's not spinning as nicely. Don't get why. When we meet problems with this, there's always going to be a solution. Tracer 0 up top there. Unfortunately, I have. Maybe I've set. Oh yes, of course I found the problem. So now this is updated 7 times instead of once. Now it's much faster. We've solved the problem. That was quite. It's very easy. Feeling of embarrassment when I miss a problem that takes so long to solve such a simple solution. Now we finally done the animation, but the last bit is interactivity. First, we're going to define some on key presses, like left and right presses, on key presses to on on key press speed up and define speed up. Okay, stop it. In fact, nothing here. Global speed, so that we're able to use a variable speed in functions. Speed plus equals 1. Ooh. Speed display dot clear. Speed display dot right. Speed. That's poor. Speed. Plus string speed font equals. Oh my god. Arial these annoying typos. 50. So pixels. Oh, bold. We go to Elijah's to center. Center. I know it's the American spelling, but that's how it is. Yeah. I'm also going to make it clear here that it's the main program. And do I need to make it? Oh yes, I'm also going to make it clear that the top is configuration. Even though it's probably already obvious. Okay, guys. Oh, we could also set interactivity to be half done. And right now, we're actually quite almost there. Oh, I can't believe it. I'm almost can't believe it now. We just go back to OnKey press speed up, and we can only speed up right now. In fact, we can't speed up at all right now because we haven't defined OnKey press functions yet. Down, go boot. It's just simple as that. Arial 50 bold, like I said, so where the OnKey press functions are ready. Last bit of work we need to do is to change the we've got to change the speed display settings. Not that. Ah, yes, here. Speed display config. Speed display turtle. Speed display the high turtle. Display the up speed display 0,400, which is basically the top of the screen. Speed display the right. This is only temporary for press left or whoops, not that. Right, left, right, left, right, left, right to adjust speed. Font equals whoops Arial 50. How do I Arial or Arial? Don't know how to actually pronounce that name. Maybe I've been pronouncing it Arial or Arial Run for 15 years. Align equals center. Let's see what we have now. Oh, we still have a spinning bike. Oh, we do have press left or right to adjust speed on the top. Do we have the speed settings at the bottom? I'm just going to move it here. Right. We've got it going. Now, we've got to go to speed display. Go to 0 negative 400. So at the bottom of the screen now. Speed display. zero. Right. Oh, whoops. Not like that. Speed. And then plus string speed. Bonds equals Arial 50 borderline equals center. Oh, we have 10. We have speed equals 10 right now. Left, left, or right to adjust speed. So the new user to this interactive program will know what to do. And last step is to make sure that pressing left or right actually does adjust speed. Here we're going to have a function called listen, so that the turtle will listen to keyboard inputs. And on key press. Why is this capital letters? So on key press. This is going to be called speed display plus user adjustment. On key press. Speed up. No. Left. On key pressed. Speed up. Right. Okay, not speed up, slow down. Oh, have I also made a bug here where I wrote speed up, speed, speed down? Isn't that such a thing? Slow down, rather. Oh, have we? I think we're quite. I think we're done now. Oh, yep. We're accelerated to speed 45. And the wheels are now steel. We're going to accelerate up to speed 500. Which means we'll make the trees stand still. In fact, the trees will be moving really, really, really quickly at that point, but due to the wagon wheel effect and due to the wagon wheel effect caused by the frame rate of the camera, then we will see a different perception of motion of different of objects. The reality is that the trees will not be as evenly spaced as that in a park, as and the camera will probably have a different frame rate, but but it will not appear as like this. It will be more blurry when it is really really fast, rather than just still like in a computer program of Turtle. Anyways, if you would like a explanation, if you would like to see a spinning wheel, an extra spin wheel, uh, feel free to check out the video on the screen right now. And and have a lovely summer's day. Goodbye.